Alright, so first thing we're going to do today is review what we've talked about so far on binary ionic compounds. And first let's go back and talk about covalent compounds. That's when two or more nonmetals share electrons. We use prefixes when naming those corresponding to the number of atoms. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, and 9 is nona, 10 is deca. And they tell us the number of atoms that we write as subscripts. So this first one, if I was going to name that, is 2, P is phosphorus, would be diphosphorus. And then 3 for oxygen, 3 oxygen atoms, it would be trioxide. Alright, now ionic compounds are different. That's when a metal transfers electrons to a nonmetal. You know, metals to the left of the stair-step line, that's how I know if something's a metal. If it's to the right of the stair-step line on the periodic table, that is a nonmetal. So when they do this, when metals lose electrons, they form positive ions called cations. And then when a nonmetal gains electrons and it has more electrons than protons in, it forms a negative ion called an anion. The opposite charges bind, forming a compound. We do not use prefixes when naming these. This is how we distinguish between these two different types of compounds. So an example, CaCl2, I named the metal first, which would be calcium. Then I named the nonmetal. The nonmetal is always written second. The metal is always written first. Then I named the nonmetal, drop the IDE. That would be chlorine would become chloride. That would not be calcium dichloride. That would be wrong. It's calcium chloride. So always look at the first element in the compound. If you have, this one, it's a nonmetal. The second element is always going to be a nonmetal. If it's a nonmetal, that means it's covalent. The first element in this one is calcium. It's a metal. That has to be an ionic compound. Alright, so we talked about what type of ions each column forms. This first column, they form a +1. If you didn't write this down on your periodic table, you should, because that's one you're going to be using on working problems and taking quizzes and tests. The group 2A, they form a +2. Now we skip over these transition metals for right now. We're going to come back and talk about those. But it goes to group 13, they form a +3. Then group 14, they don't really form ions, so we're not going to worry about those. Group 15, they form a -3. Group 16, where oxygen is, they form a -2. Group 17, they form a -1 because they need 1 electron to be stable. They're going to get that and form a -1 ion. Then the last group forms 0 charge. They're neutral and they don't bind with other elements. They stay by themselves. Alright, so to talk about the transition metals, that's the ones in the middle here, as you're transitioning from metals to nonmetals on the periodic table. Now if we look, 2 of those have certain, form just 1 ion. Problem with transition metals is most of these are what's called multivalent. They can form more than 1 ion. For example, iron. Iron can form a +2, where it gives up 2 electrons, and it can also form a +3. So we can form 2 different compounds with the same nonmetal. You can have 2 different iron oxides. But zinc is always a +2. And silver is always a +1. That's Ag. So we need to memorize those. We need to write them down on the back of our periodic table. Now, before we come back to that, let's look at if we're writing binary ionic compound formulas. Now, the other day we just talked about how to write them from starting with ions, but now how about if we're given the name of it and we want to write the formula? So you can write the formulas for the cation and the anion, including the charges. So barium, I know barium, I look it up. It's in group 2A. I know they form positive 2. I write it as a superscript. And then I write the anion, which is chlorine, and it is Cl. I look it up. It's in group 17 or 7A. And I look at the ions they form as -1. I write that up here as a superscript. Now, I check to see if the charge is balanced. If I add those up, do they equal 0? +2 plus -1 equals +1. They do not equal 0. So I can't just mark them out. And if they balance, I will cancel them out and write the formula. I can't do that. If they don't balance, I want to cross the charges and write them as subscripts in the formula. Do not include the positive or negative part of it. Alright, so I'm going to just, mark out the positive and negative. I'm going to bring the 2 down here. I'm going to bring the 1 down here. And I write that as BA1, except I don't put the 1. It's understood. And then Cl2 as a subscript. I do not leave it like this. I don't do that. That's wrong. I cross those, and I also don't bring my positive negative down. And then I write, that's the formula. It takes 2 chlorines to balance out the bariums. Now, what other way you could do this, if that's kind of confusing to you? I'll show you one other way. If I know I got barium and it's a +2 and chlorine's a -1. Another way I could do this would be if I have, I have a total +2 charge here, I need a -2 to balance it out to make it equal 0. So I would need another chlorine ion. So then to write the formula, it would be Ba and then Cl2. That's just another way of doing it if you'd like to work them that way. Alright, so another example, if I have magnesium oxide, look at magnesium, I write the symbol Mg, I look it up, it's in group 2, so it's got a +2 charge. Oxygen is O, it's got a -2 charge, it's in group 16 or 6A. I add these charges up, they equal 0, +2 plus -2 equals 0, so I can just mark these out and write the formula. It's only going to take 1 atom of each to balance out the charge. That would be my formula. Next, for zinc iodide, now I told you, going back, zinc, write this down on the back of your periodic table. Zinc is always a +2. Silver is always a +1. Pause this video, write these down in the on your periodic table. So if I'm given zinc iodide, and I know that Zn is and I look it up, I can't go by the group number, I have to memorize it or I have to write it down. Say +2. Iodine is in group 7A or 17. It's got a -1. Now, one of 2 ways I can do this. I could look at it and go, well, I got a +2 here, a -1 here, so to make them equal 0, I need a -2 to make that equal 0 if I add them. So, to equal 0, I'm going to need or equal -2, I'm going to need another iodine, and I could write the formula. Well, it's going to take 1 zinc, and it's going to take 2 iodine to balance that out. Or I could do it the cross method. When I get right here, I'm not going to bring the positive or negative down. I'm just going to bring the 2 down here, 1 down here. I'm left with ZnI2. And last, silver nitride. Silver is Ag, and now look, silver is not one of my groups. It's not one of my groups that where I know it's charged. You know, so I have to memorize silver. You know, like I said, you got to write this down the front of my periodic table or on the back. Silver, I need to always know it's always going to be a positive 1. Nitride is nitrogen. I look, and nitrogen is in group 15 or 5A. I know that every element in that group has a -3 charge. When these are different, I'm either going to need to I can cross the charges. I'll work it that way first, and I'll work it the other way. I'm going to cancel out the positive and negative. I'm going to bring the 1 down here, 3 down here. I'm left with Ag3N1. I don't write the 1, it's understood. That would be my answer. See, if I worked it the other way, if I had silver, I know it's a positive 1. Nitrogen, I know that it's a -3. Alright, how do you balance these charges? Well, I got to add them together. They don't equal 0, they equal -2. I know this is a total of -3. To make this equal 0, I'm going to need this to be a +3 when I add them. So how do I get it to do that? Well, I got to add 2 more of these ions. And that leaves me with Ag3N. Okay, next, most transition metals have multiple oxidation states, which means they can form more than one compound with the same nonmetal. For example, iron can form cations with 2+ charge and a 3+ charge. That's how they would be written, like that and that. When naming compounds with transition metals, except zinc and silver, a Roman numeral is included to show the oxidation charge of the metal. Alright, so iron, if you see this Roman numeral, you know that that Roman numeral is telling you the charge. It's telling you that this iron, in this case, was a +2. It gave up 2 electrons. Iron 3 oxide, the formula is Fe2O3. If you notice, these are 2 different compounds. Different formulas, you know, completely different compounds. In this case, iron was a +3. Alright. It gave up 3 electrons of the oxygen, and it took 2 atoms of the irons, 3 atoms of the oxygen to balance it out to have a neutral compound. So wherever you see that, remember that does not, like iron 2 oxide, it's not telling you this. It's not. It's telling you that it's a +2 in that case. And if we have lead 2 bromide, it's PbBr2. Lead 4 bromide, this is the Roman numeral for 4. It's Ib. That would be PbBr4. So if we look at writing formulas like this, if we have an example, iron 3 chloride, these are even easier. I don't even have to look up the oxidation number of the metal. You write the formulas for the cation and anion. Cation is the metal, which is iron. And that would be a +3. That's what that number's telling me right there, that ours is a +3 in this case. Chlorine is always, if I look in group 17 or 7A, it is a -1. My charges do not balance. +3 plus -1 does not equal 0. You know, if I got a +3 here, and I need this to be a -3 to make those equal 0. So what do I need? Well, I need 2 more of these chlorine ions for a total of 3 of them. And then when I write my formula, it would be 1 atom of iron, 3 atoms of chlorine to balance out the charge. Or I could do the cross method, whichever way works better for me. In this case, I write my the cation and anion, which is just the ions formed. I'm going to cancel out my positive and minus. These numbers don't balance out. Bring that one there. Bring that one there. I write Fe. That's a 1, but it's understood. I don't put it. Cl3. I write on this subscripts. And that's what you get. If we look at a couple more examples. Chromium 2 phosphide. Now chromium, I look up and its symbol is Cr. So I'm going to write the symbols for the cation. It's the metal ion formed. And it's telling me in the name that it's a +2. Phosphide is phosphorus. Alright, P. It's in group 15 or 5A. It forms a -3 charge. Now these do not balance out. So what I could do is say, well, I got to find the at least common multiple of it. Common multiple will be 6. So I need this to be a +6. I need this to be a -6. That way if they add up to 0. So I would need to have 2 more chromiums. And I would need 1 more phosphorus. Then when I write my formula, it would be Cr3P2. Or I could do it the other way. Cr is a +2. Phosphorus is a -3. I'll cross these. I'll mark out the positive and minus. I don't need those. Bring that there. That there. It becomes Cr3P2. Okay, next 10,4 oxide. So if I look up 10, I look it up, its symbol on the periodic table, it is Sn. It's telling me in the name, since it's a transition metal and it can form more than one oxidation number, it's telling me that it's a +4. That's what IV means. Oxygen is a -2. Now this one's a little tricky, so we're going to have to be careful. So if I look at it like +4 and -2, well, to make them add up to 0, we've got a +4 plus -2 equals +2. I need this to be -4. So I add them together, that would equal 0. So okay, I just need one SN, but I would need another oxygen ion. So when I write this formula, I would have SN, just one of those, O2 would be the correct formula. And that's easy to see if you do it that way. But it's different. It's different if we're going to cross those. So if I see that they're different numbers, I can't just mark them out and write the formula. I'm going to just cross the numbers, bring the 4 here and the 2 here. And when I write it, it becomes SN2O4. But remember, these are ratios, these numbers are, so they can be reduced. If I bring them down, cross them, I need to reduce them. That would reduce to 1 and 2. So when I rewrite it, it would be SN1O2. Now, naming, to review over the ionic compounds, I simply name the metal, I name the nonmetal, drop the ending, and add IDE. No prefixes with ionic compounds, only covalent. So I always look at the first element. First element in this bottom example, Zn3N2. I look, zinc is on the left side of this stair-step line. It is a metal, so that's got to be an ionic compound. So I'm going to name it like ionic compound. That is zinc nitride. And then this bottom example, CaSe, I look at the first element, that is calcium. It is in group 2A. It's on the left of the stair-step line. It is a metal, so this has to be an ionic compound. So I name it like one. Name the metal, calcium. Name the nonmetal, drop the ending and add IDE. It's calcium selenide. Selenium becomes selenide. Okay, so now you have some practice problems to do. You need to work these. When you're completely finished, you can check your answers with the PowerPoint.